Hi everyone. Sorry the weekend's done so soon, but if there's any good news, at least we get a gradual transition back into it. Today will be the gray day, your independent learning. So I'm going to put a little bit on you guys. Should be pretty simple though. We're going to need the textbook and also FET though. So I'm on my iPad right now, of course you can see. And I'm going to show you, at least in the textbook, what I first want you to do. So we're in chapter 11. Since we last spoke, we kind of ended on section 3, properties of waves. I'm not going to jump into it, but what I need you guys to do on your own for that chapter, and it's pretty brief, I need you guys to look up wave types, which if you can see it at the bottom, it begins on page 612. And there's two major types. This is going to help you guys understand when I'm talking in the simulations what I'm referring to. And then also, I'm going to scroll on the bottom, when I get to the end of that section on page 619, there's a very important idea on that page. I want to make sure you are clear that you know that as well. All right, today though is going to be focusing on section 4, which is going to be wave interactions. Sometimes you'll hear this referred to as superposition principle. Just giving you the heads up right now, it's called constructive and destructive interference. That's the big thing. Now you can again skim through that. That's going to be, of course, the second half of this video though. And go ahead and stop though. We'll also talk about reflections as well. I'll do them in opposite order though. I'll show you the reflections on the simulation first and then the interactions. But stop, don't go on to standing waves. That's going to be kind of the big final picture, okay? So do that in the textbook first, and then, of course, you're going to go to FET. Now, on my iPad, it's clearly going to look different than when I go to it on the website. But you guys, as always, will go to simulations, play with sims, and then we're not really going to be in motion anymore. We're going to be in waves and sound. On this, though, what's kind of cool is I can just search right away. And the one that we're going to want is the waves on the string in the middle. And it should be HTML5 for you guys and look like this. Okay. Really, this is going to help you complete the concept builder, which is going to be your task for the day. And I won't go through every single scenario, but you guys knowing how to use this, that'll help you kind of get a visual for what I'm talking about and what's going on. So I'll probably do 2 examples maybe for you guys. All right, so we're going to change some features real quick. It's fun to play with this and watch this string go crazy. But I'm going to change it from manual to pulse. Top left up there if you didn't see it. Down in the bottom middle, I'm going to get rid of damping, which means I don't want to lose any energy. And that's a big idea that waves, if you read the end of the section, waves transfer energy, which I'll show you in the simulation. And then everything else we can kind of leave the same. I guess we can do slow motion just so it's not going too fast. But what's going to happen is I'm going to, with this pulse button on the left here, it's the green one, right in this rectangle above amplitude. I'm going to create a pulse, and basically what it's doing is it's creating a vibration. Just like simple harmonic motion with the pendulum, you have this vibration back and forth. It's going to start this vibration. Now, first thing I want you to focus on are the green dots on this string. When this vibration occurs, the green dots move up and down. All right, but the wave itself is moving to the right. So, in terms of types of waves, this is a transverse wave. If you're confused by that, go back to the textbook. But the big thing I need you to be clear on is that if the matter itself, the green dots, if the matter itself is moving up and down, but the wave is moving left and right, then that means waves do not carry matter. This shouldn't be too much of a surprise. What they carry is energy. Because think back to our little graphing activity we did with the pendulum. The amplitude represents the energy. So you can see the amplitude is what's actually being transferred back and forth. All right, now what you'll notice in terms of the wave traveling on this is it gets to the ends, and what it then hits are what we call boundaries. I'm not going to go too nuts with this right now, but right now you can see it's reflecting off of the boundary, or bouncing back is another good word for reflection. If the boundaries are not allowed to move, which we call fixed, then it reflects on the opposite side. In the top right, I can actually change it from being fixed to loose. It's going to reflect again, but if it's loosed, it will bounce back on the same side. Okay? So I'm going to pause this. And now we're going to kind of get into... I want to just get rid of that pulse. So hit restart at the top left there to just get rid of the pulse. Now I want to get into the big idea, which is going to be your concept builder. All right, we're going to talk about interference between multiple pulses. All right, so what's going to happen is you're going to have multiple pulses on this string, and the string represents a medium, a material. All right, what they're going to do is they're going to interfere, and choose your words wisely. Interfere does mean something in particular. What they're going to do, and I'm going to go ahead and start one. I'm not saying collide for a reason because they're going to approach one another, and then if I pause it, I can kind of do it step by step. They're not going to bounce off because remember, they don't carry matter, they carry energy. So what's going to happen is they're going to interfere, which essentially means they're going to overlap and occupy the same space at the same time. But what happened? Well, when they interfered, the amplitude got bigger. This is what we call constructive interference. Why did that occur? Because they were on the same side. All right, they were both on the top half of this. Some of you, though, might be like, well, maybe they did bounce off, though, because you can't really tell which one's which. Well, if I play this, and then they switch to opposite sides, look at the one that's on the left right now, the bottom side moving to the right. When I play this, if they do bounce off, it would then go back to the left on the bottom side. If it does pass through, like we said, though, the one that's on the right afterwards should be on the bottom. That's kind of a small detail. The big detail is, well, what happens in terms of the energy, the amplitude when they interfere? Well, if they're on opposite sides and they're the exact same amplitude, this isn't going to be constructive. Because they're on opposite sides, they're going to cancel each other out, and we're going to get what we call destructive. So for a brief moment, it basically is completely gone, the energy. But that's just because they've overlapped perfectly and had the exact same amplitudes on opposite sides. But then you can see afterwards they're still there. This one's, again, more confirmation that they pass through because you can see the one that started on the left side on the bottom is now moving to the right, still on the right side on the bottom. All right, so you can sit here and play with this all day. I think what you're going to find out, though, is that when you go to concept builders, they're not going to be the same amplitude like these two. So what's going to happen is you're kind of going to get one that has this amplitude, and then if I change this amplitude to be really big, you'll get one with a different amplitude. So you might get different amplitudes for during the constructive and clearly different for the destructive. Okay? I'll give you a hint for the math. When you do the resultant part, when they're interfering, it's basically the sum of the two amplitudes, and be mindful of positive and negative because that'll help you with whether it's constructive or destructive. All right, hope this helps, guys. Good luck, of course, on that. And remember, I'll have some office hours tomorrow, so if you're just completely stumped, you can always tune in and I'll give you a little more guidance, okay? See you guys. Have a great day.